Hello dear students, in this video I will continue with chapter 6 Permutations and Combinations. Here I will discuss about permutations and solve the first 9 questions of exercise 1.3 of CBSE Book student support material. Now first we will see what are these permutations. A permutation is an arrangement of objects in a definite order where we take some or all at a time. Now first we will see the formula for the arrangement of objects in a definite order when all the objects are distinct. The number of permutations of n different objects taken are at a time where 0 less than or less than or equal to n and the object do not repeat is given by, it is npr, which is n factorial upon n minus r factorial. This n factorial upon n minus r factorial is nothing but it is n into n minus 1 into n minus 2 into up to etc. n minus r plus 1. Now how we get this? There is already a question in the first exercise. So if you want to find the number of permutations of n different objects when we take r objects at a time where r lies between 0 and n and the objects do not repeat, then we can use the formula npr equal to n factorial upon n minus r factorial. Now there are some more theorem. The number of permutations of n different objects taken r at a time when repetition is allowed is n raised to r. Then the next we have the number of permutations of n objects where p objects are of the same kind and the rest if any are different, it is given by n factorial upon p factorial. So the number of permutations of n objects where we have p objects of the same kind and the remaining objects are different, then it is given by n factorial upon p factorial. Now moving on, the number of permutations of n objects where p1 objects are of one kind, p2 objects are of the next kind, up to etc. pk objects are of the kth kind and the remaining are distinct, it is given by n factorial upon p1 factorial into p2 factorial into up to etc. into pk factorial. How these formulae are useful in solving problems, we will see while solving the exercise questions. These are the questions from exercise 1.3 of chapter 6 Permutations and Combinations. The first question, find n if n minus 1 p3 is to n p4 equal to 1 is to 9. So we have to find n when this condition is satisfied. So given n minus 1 p3 is to n p4 equal to 1 is to 9. Now we just now saw the formula for npr. npr is given by n factorial upon n minus r factorial. So here n minus 1 p3 will be n minus 1 factorial upon n minus 1 minus 3 factorial is to this np4 is nothing but it is n factorial upon n minus 4 factorial. This is equal to 1 is to 9. Or we have n minus 1 factorial upon n minus 4 factorial into n minus 4 factorial upon n factorial. Since this is 2, we can multiply and write the reciprocal. This is equal to 1 by 9. Now these two will go. So this implies n minus 1 factorial upon n factorial, we can write it as n minus 1 factorial into n equal to 1 by 9. So from this we get n equal to 9. So if this condition is satisfied, then the value of n is equal to 9. Next question, find r if 9pr equal to 3024. First subdivision we will do, then we will go to second subdivision. First, 9pr is equal to 3024. Or we have 9 factorial upon 9 minus r factorial. This is equal to 3024. So from this we have 9 minus r factorial equal to 9 factorial upon 3024. Now 9 factorial we can write it as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 upon 3024. Now let us simplify from 9. So 3024 it will go 336 times in 9. Then moving on to 8. Here we have 42, then 7 will go 6 times, then these two 6 will go. So we get 1 into 2 into 3 into 4 into 5, which is 5 factorial. So we get 9 minus r factorial equal to 5 factorial, or we have 9 minus r equal to 5, which means 9 minus 5 is equal to r. Therefore, r equal to 4. So if n p r equal to 3024, we have r equal to 4. That is 9p4 is equal to 3024. Now moving on to the second subdivision. 5pr is equal to 2 into 6pr minus 1. 5pr, it is nothing but is 5 factorial by 5 minus r factorial. This is equal to 2 into 6pr minus 1 is 6 factorial upon 6 minus of r minus 1. So it is 6 minus r plus 1 factorial. So this implies 5 factorial upon 5 minus r factorial. This is equal to 2 into 6 factorial. We can write it as 5 factorial into 6 upon 7 minus r factorial. Now these two 5 factorial will go. Here we can cross multiply 7 minus r factorial. So we get 7 minus r factorial upon 5 minus r factorial. This is equal to 12. Now 7 minus r factorial, we can write it as 5 minus r factorial into 6 minus r into 7 minus r upon 5 minus r factorial. This is equal to 12. So these two will go. So we have 42 minus 13r plus r square equal to 12. Or we have r square minus 13r. Here plus 42 minus 12. So it is plus 30. This is equal to 0. So from this we get a quadratic equation in R. So we can simplify it as, here 30 is 3 into 10. So r minus 10 into r minus 3 equal to 0. From this we get r is equal to 3 or r is equal to 10. Now we cannot take r is equal to 10 because r should be less than 5. So this is r is not equal to 10 since r is less than 5. Therefore r equal to 3. So if 5pr equal to 2 into 6pr minus 1, then we get r is equal to 3. Next question, prove the following. Npn is equal to 2 into npn minus 2. So first let us take the left hand side. Npn is n factorial by n minus n factorial, that is 0 factorial, so it is n factorial. And the right hand side is 2 into np n minus 2, so it is 2 into n factorial by n minus of n minus 2, so n minus n plus 2 factorial. So these two will go. So we get 2 into n factorial by 2 factorial. So this is n factorial, which is equal to the left hand side. So both left hand side and right hand side are equal. Now let us take the second subdivision. N minus 1 PR plus R into N minus 1 PR minus 1 equal to N PR. So for the second subdivision, first let us take the left hand side. So left hand side is N minus 1 PR plus R into N minus 1 PR minus 1. So this is equal to N minus 1 factorial upon N minus 1 minus R factorial plus R into N minus 1 factorial upon N minus 1 minus R plus 1 factorial. So this is equal to N minus 1 factorial upon N minus 1 minus R factorial plus R into N minus 1, here minus 1 plus 1 will go, factorial upon, here this N minus R factorial we can write it as N minus R minus 1 factorial into N minus R. So that the LCM will be N minus R factorial. The numerator N minus 1 factorial is common, it can be taken outside. So here we have N minus R plus R in the numerator. So these two will cancel out. So we have N into N minus 1 factorial upon N minus R factorial. Now N into N minus 1 factorial is N factorial upon N minus R factorial. So this is equal to N PR, which is the right hand side. So we have proved. Next question, how many 3-digit numbers are there with no digit repeated? So here if we see a 3-digit number, it consists of the hundreds place, tens place and the ones place. And the various digits are 0, 1, 2, 3, 4, 5 till 9. Now the hundreds place can be filled in 9 ways. Because we cannot include 0. If we include 0, then it will become a 2-digit number. So the hundreds place can be filled in 9 ways. Here the digits should not be repeated, so the remaining 2 places it can be filled using the remaining 9 digits. So the remaining places can be filled in 9 P2 ways. So by multiplication rule, the total numbers, these 3-digit numbers where no digits are repeated, it is 9 into 9P2. So it is 9 into, here 9P2 we can write it as 9 into 8. Because 9P2 is 9 factorial by 9 minus 2 factorial, which is 7 factorial. So this is 7 factorial into 8 into 9 upon 7 factorial. So here I have written directly as 9 into 8. So this is equal to 81 into 8, it is 648. So this is the answer. Next question, how many 4-digit even numbers can be formed using the digits 1, 2, 3, 5, 7 and 8 if repetition of digits is not allowed? So here we have to find the number of 4-digit even numbers that can be formed using these digits 1, 2, 3, 5, 7 and 8, and the repetition of digits is also not allowed. So here the 4-digit numbers consist of ones, tens, hundreds and thousands place. Since we are concerned about even numbers, the ones place, it can be filled only using 2 and 8. Only then the number will be even. So the ones place can be filled in 2 ways. The remaining digits will be 1, 2, 3, 4, 5 and the remaining places are 1, 2 and 3. So the remaining places can be filled in 5P3 ways. So by multiplication rule, the required numbers will be 2 into 5P3. So it is 2 into 5 into 4 into 3. So this is equal to 20 into 60, so it is 120. Next question, how many numbers between 6000 and 7000 formed with the digits 0, 1, 5, 6, 7 and 9 are divisible by 5 if repetition of digits is allowed, if repetition of digits is not allowed. Now we need to find the numbers between 6000 and 7000 which can be formed using these digits that are divisible by 5. First we will see the first subdivision. So let us take the first subdivision when repetition of digits is allowed. When repetition of digits is allowed, this is the ones place, tens place, hundreds place and the thousands place. So here the thousands place, the number should be between 6000 and 7000. So it can be only 6. So the thousands place can be filled only in one way. Since the digit should be divisible, the number should be divisible by 5, the ones place, it can consist of only 0 and 5. So ones place can be filled in 2 ways. And then the remaining places each, it can be filled in 6 ways. The hundreds place can be filled in 6 ways and the tens place can be filled in 6 ways. So the remaining places each can be filled in 6 ways. So by multiplication rule, the required numbers will be 1 into 6 into 6 into 2, or it is equal to 72. And one more thing, this number will include this 6000. So we have to reduce 1. So it is 72 minus 1, which is 71. So the numbers between 6000 and 7000 formed with these digits and divisible by 5 when the repetition of digits is allowed is 71. Now let us consider the case when repetition of digits is not allowed. So the second subdivision. So here we have the ones place, tens place, hundreds place and the thousands place. Here again the thousands place can be filled in one way and the ones place can be filled in 2 ways. This is in 2 ways and in 1 way. So the remaining digits which are left are 4 and the remaining places are 2. So the remaining places can be filled in 4p2 ways. So by multiplication rule, the required numbers are 2 into 1 into 4p2, or it is equal to 2 into 1 into 4 into 3, or this is equal to 24. So when repetition of digits is not allowed, the required numbers between 6000 and 7000 which can be formed with these digits that are divisible by 5 is 24. The next question, a family of 6 brothers and 4 sisters is to be arranged for a photograph in one row. In how many ways can they be seated so that all the sisters sit together? No 2 sisters sit together. First let us take the first subdivision. There are 6 brothers and 4 sisters and they are arranged for a photograph in one row. We need to find the number of ways in which they can be seated if all the sisters sit together. Let us take the first subdivision. So the 4 sisters, they can be arranged in 4p4 ways. This is 4 factorial. Now if we consider all these 4 sisters as a single person and the 6 brothers, because these 4 sisters have to be, all these sisters have to sit together. So if we consider them as a single person and the remaining 6 brothers with this single person, 7 person, they can be arranged in 7p7 ways, or this is equal to 7 factorial. So by the multiplication rule, the required number of ways is equal to 4 factorial into 7 factorial. So it is 4 factorial into 7 factorial. Or it is equal to 1 into 2 into 3 into 4. 7 factorial is 2 into 3 into 4 into 5 into 6 into 7. When we multiply all these, we get 1,20,960. Now moving on to the second subdivision. When no two sisters sit together. So this is the second subdivision. So here we have the 6 brothers who can sit in 6 places. So 6 brothers can be arranged in 6p6 ways. So this is equal to 6 factorial. And here no sisters should sit together. So the sisters can occupy either this place or this here, 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 or here, or in between these brothers. So the number of places available for sisters to occupy is 1, 2, 3, 4, 5, 6, 7, and there are 4 sisters. So the 4 sisters can be arranged in these 7 places in 7p4 ways. So by multiplication rule, the required number of ways is 6 factorial into 7p4. Or this is 1 into 2 into 3 into 4 into 5 into 6 into 7p4 is 7 into 6 into 5 into 4. Now when we multiply these two, we get, so this is equal to 6,04,800. So these are the number of ways in which no two sisters will sit together. Next question, how many words with or without meaning can be made from the letters of the word Tuesday, assuming that no letter is repeated if the first subdivision all the letters are used at a time. Now this is very easy. When all the letters are used at a time, the required number of words is, the number of letters is 1, 2, 3, 4, 5, 6, 7. So it is 7p7. Or this is equal to 7 factorial, which is 5040. The next subdivision, when 5 letters are used at a time. So when 5 letters are used at a time, there are 7 letters available and 5 letters are used at a time. So the required number of ways will be 7p5, or it is equal to 7 into 6 into 5 into 4 into 3. Or this is equal to 2520. Then the next subdivision, all letters are used but first and last letter is a vowel. So here we have the 7 letters. First letter, second, third, fourth, fifth, sixth and seventh. Here the first and last letters are vowels. So when first and last letters are vowels, here we have 3 vowels, U, E and A, and we have 2 places. So the 3 vowels can be arranged in 2 places in 3p2 ways, or this is equal to 3 into 2. And now the remaining places are 1, 2, 3, 4, 5, and the remaining letters are 5 letters. So the remaining letters can be arranged in 5p5 ways. So the total, this is equal to 5 factorial. So the total ways is equal to 6 into 5 factorial. 5 factorial is 120. So this is 720. Now moving on, In how many ways can the letters of the word permutations be arranged if the words start with P and end with S? So here, when the words start with P and end with S, the remaining number of letters are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are remaining 10 letters. Now these letters, they can be arranged in 10 factorial upon. Here we can see that the letter T is repeated. So it is repeated twice. So it is 10 factorial upon 2 factorial. So by multiplication rule, the required number of ways, since the first and last letter are fixed, we have 1 into 10 factorial upon 2 factorial. Or this is equal to, when we simplify, we get 18,14,400. This is 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. The next subdivision, there are 5 letters between P and S. Now, when there are 5 letters between P and S, if P occurs before S, say for example, if P is the first letter, then after P there are 5 letters, and after that we have S. So the position of S will be 7th. Or the position of P is second, and after this second position there are 5 letters, so that the position of S is 8th. Then if the position of P is third, after this P there are 5 letters, so 4, 5, 6, 7, 8. This is the position of S, 9th. Similarly, if the position of P is 4th, after 5 letters, the position of S, it is 10th. If the position of P is 5th, then the position of S is 11th. If the position of P is 6th, then the position of S is 12th. Here this word has got only 12 letters, so we cannot go beyond that. So when P occurs before S, now this happens in these many number of ways, 1, 2, 3, 4, 5 and 6. Now similarly, when S occurs before P, then the number of ways will be, it will be the other way around. Position of S will be here, position of P will be here. Again the same rule will follow. So the number of ways is equal to 6. So we have these two cases and the remaining letters. The remaining letters, if we leave out this P and S, remaining we have, I think 10 letters. Yes, 10 letters are there. The remaining letters can be arranged in 10 factorial upon 2 factorial ways. Because T is repeated here. So by the fundamental principle of counting, the required number of ways will be 6 plus 6 into 10 factorial upon 2 factorial. Or this is 2 into 6 into 10 factorial is 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 upon 2. Now this, when we simplify, we get this as equal to 2 crore 17 lakhs 72,800. Now the next subdivision. In how many ways can the letters of the word permutations be arranged if the vowels are all together? Now the vowels are here. Vowels are E, U, A, I and O. All the 5 vowels are here. So the 5 vowels can be arranged in 5 P5 ways, which is 5 factorial. Now after removing these 5 vowels, the remaining letters are 7. Now if we consider these 5 vowels as a single letter because they have to occur together by multiplication rule, the required number of ways will be 8p8 upon 2 factorial, since t is repeated into the number of ways in which the vowels can be arranged, 5 factorial. So this is 8 factorial upon 2 factorial into 5 factorial is 120. So it is 2 factorial and 2 will go. So we have 3 into 4 into 5 into 6 into 7 into 8 into 120. Now this, when we simplify, we get 24,19,200. I hope this video was useful for you. Thank you for watching.